Hello all. So we have been discussing about this microsystem for micro robots. Today we will discuss about the third part of this microsystem for micro robots related applications. Ideally, we have been discussing about different functionalities related to this microsystem. In today's module, we will discuss about the concept of integration. That is, like we have been discussing about actuation, we have been discussing about the sensing mechanism. So when we try to integrate it, so it comes as a kind of a complete system which caters the required functionality. So in today's lecture, in this entire module, so we will be discussing about the different assemblies, self-organized assemblies, different mechanisms which are involved in such kind of assemblies. We will be discussing it in detail. In addition to this, we will also be discussing about two important aspects. One is called as a micro aerial vehicle and another one is a kind of a multi-robot system. So as far as these micro aerial vehicles are concerned, so it has a potential application towards some of the strategic areas, which includes defense, which also includes space related applications. It is also effectively used for like inspection, pipeline inspection, AC duct inspection, etc. So we will discuss in detail about the different classification of these micro aerial robots, and then we will also discuss about the multi-robot system. Now, as a first part, when we are talking about this micro assemblies, so these micro assemblies are defined as the process of assembling the micro parts, ideally the form of organizing, positioning and collecting the microscale component with dimensions typically in the ranging from few micrometers to several micrometers. So ideally what happens is, so when we have a kind of a micro actuators, and when we try to assemble these micro actuators, we try to ensure that the entire system is within the limit and it caters the required functionality. So either if we have a kind of a micro sensors in place, or these micro assembling of these micro sensors or integrating of these micro sensors, appropriate feedback systems, etc., needs to be taken up into consideration. Okay. Now, some of the major aspects which we may need to look into it is this manufacturing capability for individual micro components, which has advanced significantly, and the assembly of the components into complex functional microsystem has become a kind of a critical challenge in such kind of micro assembly based systems. Now, in this particular aspect, so like one way is through a kind of a adhesion analysis, or in other way through by applying certain amount of magnetic field. So we can just assemble these systems based on the functionality. So ideally, so we try to take these scaling effect forces that are insignificant at the macro scale become a major dominant player when we try to consider it in a micro scale. So ideally, like we have discussed a lot about this electrostatic charge, generation of electrostatic charges, etc. So these electrostatic charges on a micro level, so it can be helpful for manipulating the system for appropriate micro assemblies or sub assemblies. So for example, so when a part is handled are less than a 1 millimeter in size, the adhesive force between the gripper and the object can be significant compared to the gravitational force. So this is through this concept, so we can establish this kind of micro assemblies or the micro requirements. So as far as these micro assemblies are concerned, some of the key challenges which are involved in micro assemblies, which includes, one is a part handling, another one is positioning precision, third one is the kind of a surface roughness or the gravitational force. So when we try to closely observe into this, part handling is something like, so it's a kind of a gripper which is being deployed in such kind of micro robotic system. When we try to talk about positioning and precision positioning, so as far as in this particular case is concerned, like let's suppose I have a kind of a needle. So this needle needs to be positioned for appropriate measurements or appropriate manipulation aspect perspective point of view. So in those conditions, these kind of micro assemblies play a vital role. Next is with reference to control of surface force as well as gravitational force. So when we try to consider a system, so a kind of a micro system, so ideally like one is a kind of an intentional force which is getting generated, which we intentionally try to induce on the surface so that we get a kind of a manipulation. So another one is a kind of a undesirable forces, like in some certain cases there is a chance that gravitational force, we may need to develop a mechanism or a microassembly mechanism which will overcome these gravitational force for appropriate manipulation or for appropriate control over the system. So this is one of the important key aspects. So appropriately we try to design the micromechanical systems for generating such kind of, or to overcome this gravitational force, or to encash these surface forces. Now, as far as these technique is concerned, so we just classify this technique into two. One is a kind of a mechanical assembly which is available. Then we have the self-assembly, and then we have the hybrid assembly. As far as mechanical assembly is concerned, so we try to integrate these micro components to assemble the system based on our requirement. As far as self-assembly is concerned, so like these systems or the subsystems get self-assembled by giving an appropriate actuation or by giving an appropriate forces, it tries to create a self-assembly. Third is a kind of an hybrid assembly. So as far as in this hybrid assembly is concerned, both mechanical assembly and self-assembly works together to create a kind of a micro manipulation in such a way that the system is organized to get an appropriate functionality. So in fact, regarding this, we will be discussing it in the upcoming case studies also, where there are certain amount of magnetic nanoparticles are there. So when we try to create a kind of forces to it, so appropriately these magnetic nanoparticles will try to align itself to form a structure, and those structures can be efficiently deployed for different applications. In fact, there is a concept called ferrofluid based structures. So as far as these ferrofluid structures are concerned, so these structures are like, so these structures have such kind of pillar kind of combinations. So these pillar kind of combinations are like attracted by certain amount of magnetic force which is being deployed, so that it form a kind of a structure, and using this structure it can be used for like a different manipulation related application. Of course, we have discussed about this in the earlier classes also. Now let us see, or let me just try to correlate with reference to the scaling laws and the physical effect. So as far as the physical phenomenon behavior is concerned, so they behave differently at the micro scale, and it requires a specialized assembly approach. So there are different key differences at the micro scales. Some of the key difference include the surface forces. So some of the surface forces includes the adhesion, the capillary forces, the electrostatic attraction which is dominating over the body surface. Then there is an increased significance of frictional effect which is being imparted over here. However, there is a reduced importance of the inertial force which is generated. As far as this pronounced influence of electrostatic force is one of the key aspect which is also considered for the microscale. So these microscale effect fundamentally change manipulation strategies. So they often requiring a kind of a non-intuitive solutions compared to the macro assembly. So if you closely observe this micro assembly, so we can classify this micro assembly into two. One is called as a surface tension, van der Waals forces, and the electrostatic forces, which will try to contribute towards the micro assemblies. The other one part is with reference to surface tension and the gravity. Now, when we try to look into the overall scale of this particular micro robotic related applications, so when we try to consider under nano, micro and macro level, so the surface tension, van der Waals forces and electrostatic forces are well participating in the nano and the micro range. However, the surface tension and the gravity is well participated along the macro range. So in the case of a macro range, so ideally between 1 mm to 1 centimeter, so where there is a kind of a surface tension and a gravity which tries to participate, and we try to develop the system. Whereas in the case of a nano and a micro level, there is going to be a kind of a surface tension, a van der Waals and the electrostatic charge which try to get contributes towards development. Now, as far as on a nano level is concerned, so we have the nanoparticle in place. Then there is a swarm kind of structures are there. Then there are few magnetic based materials or few electrostatic charge generated based materials which are available, which is heavily contributing towards this surface tension or van der Waals forces or the electrostatic charge. When we try to look into the, when we increase the scale to the micro level perspective point of view, we have the micro robots, the cell structures, so appropriate drug delivery system, and then there are some mechanical grippers. So these systems are well controlled by these kind of nanoparticles which are available. Now slightly when you try to increase the capability with reference to the with reference to the scale, we have the MEMS and the micro manipulation system, which plays a vital role towards developing a kind of a macro structure. So in all these cases, like these are some of the applications where a micro manipulation and its relevant micro robotic development comes into the picture, and the appropriate forces which are evolved, or the appropriate forces which can be used for controlling these systems, includes the surface tension, the van der Waals forces, the electrostatic charge, and the surface tension and the gravity. Now in this entire module, so we will discuss about some of these forces, how these forces are contributing towards development of such kind of structures in detail. Now in addition to this, let us discuss about a simple mechanical system. So before going into this, let us discuss about a simple mechanical system which is called as a gripper based microassembly. So as far as this gripper based microassembly is concerned, so we all are aware about this gripper based micro manipulation. So in this gripper based micro manipulation is concerned, either this micro manipulation can happen by a motor control, or the manipulation can happen because of the electrostatic charge. Okay, so what happens is, like as and when once we go for a finer finer size of the structure, so these particles will try to leverage certain amount of adhesion or certain amount of repulsion, and appropriately we can observe a kind of a variation which exhibits. Okay, so these are called as a gripper based microassembly. So as far as this gripper based microassembly is concerned, as the gripper approaches the part, the electrostatic attraction may cause the part to jump off the surface into the gripper with an orientation dependent on initial charge distribution. So when the part is placed to a desired location, it may adhere to the gripper than to the substrate, preventing its accurate placement. So like it's a kind of a pick, move, place operation with micro parts, and due to sticking effect, parts may be attracted to the gripper during the approach and release phase, causing an inaccurate placement. So this is one of the major impact with reference to these gripping and micro assemblies. Now let us see some of the different technologies which exhibits, and we can also discuss about appropriate key application of this micro assembly based system. So as far as in this overall technologies which are being deployed for these micro assembly systems are concerned, so first let us consider the simple building blocks. So as far as some of the key building blocks which are being participating with reference to this micro assembly includes the microparticle, the multiple objective, and the cells. So as far as these microparticles are concerned, the micro component of various materials and shape are used to build microstructures for verification or practical purpose. So micro or nanoparticles with swarming behavior for multidimensional manipulation, transport, and delivery may be considered for this microparticle related applications. Now when we consider this multiple objective, so we have a micro components of various materials and shapes are used to build these microstructures for verification or for certain amount of practical purposes. Now when we try to talk about the cells, so like there are wide varieties of cells out there, like natural cells or microparticle modified cells, which means that we have a cell structure which is being completely encapsulated with a kind of a microparticle so that it can cater the appropriate micro manipulation. Then there are some artificial cells are there which are of important target for micro assembly, such as screening, packaging, and transportation related applications. Okay, now so these are the primary building blocks for any kind of micro robotic system, basically catering towards micro assembly concept of this micro robotic systems. Now, when we try to look into the overall techniques which are being evolved with reference to this assembly perspective point of view. So, we have the structure construction. So, these techniques are classified under 3 different domains. One is a kind of a structure construction, where it is mainly meant to build intricate 2-dimensional and 3-dimensional microstructure with different functions relying on the precision, efficiency and repeatability of these microassembly systems. Now, with reference to MEMS operation is concerned, we have a high precision and a stable microassembly technology, mostly completed by the commercial micro-operational platforms. Now, as far as biomedical engineering perspective point of view, it provides the prospects of targeted delivery minimally invasively or non-invasively systems. So, these are some of the key techniques which works along with the building block to cater the assemblies. Now, let us see with reference to actuation and with reference to application perspective point of view. So, with reference to application perspective point of view, so the microassembly is categorized under 4 different fields. One is a kind of a magnetic field based system. So, as far as these magnetic field based systems are concerned, they are most common and mature and non-contact micro cooperation method with strong compatibility. So, the need for object to be magnetized is a major limitation of this particular system. Now, when we try to consider the optical field, it is a kind of an excellent in-laboratory solution that enables batch automation suitable for integration with other technologies. As far as acoustic field perspective point of view, a gentle non-contact technology that is effective against clustered particles, feasible for application in fluid environment. And mechanical operation perspective point of view, it serves as a function and effector for complex system, and it has a possibility of inheriting multiple sensing functions that prospects towards the intelligence of this particular system. So, these are some of the key applications which are being catering towards the overall application towards the microassembly related system. Now, among all these systems, like we had discussed a lot about optical based users and optical based manipulation, but as far as assembly perspective point of view, magnetic based systems has been considered to be a kind of a potential player with reference to assembling perspective point of view. Now, as far as these magnetic assemblies are concerned, so the magnetic assemblies are classified as magnetic field induced assembly, so which is a kind of a very niche technology which has been effectively used for different applications. So, as far as this magnetic field induced assembly is concerned, some of the key features of this magnetic field induced assembly includes the direction control, a nanoscale based systems, a magnetic property improvement, real-time tuned, and it is highly it has a high assembly efficiency, and it has a long range translation order. As far as application perspective point of view, it has a nanoparticle assembly which with 1-dimensional anode, 2-dimensional monolayer, a 3-dimensional chiral assembly. It has a kind of a polymer films and a mesoscale structural constructions are some of the key applications of this system. Now, the next system is called as the magnetic assemblies. So, as far as in this magnetic assemblies are concerned, this is a kind of a non-contact system. It's a kind of a non-contact based system, and it's a kind of a, so you can program it and reconfigure the formations based on the requirement. Next is it has its own predictive models, and it has a kind of a jamming free assembly. And one important point is with respect to good robustness, and it has a error recovery, and it has a predictable at a static orientations. So, as far as application perspective point of view, it has a kind of a magnetic levitation orienting. It has a collective behavior, and then it has a kind of a structure construction which exhibits over here. So, these are some of the applications which has a direct relevance towards the magnetic assemblies, and these are some of the features which exhibits with reference to this magnetic assemblies. Now, in the with reference to magnetic field, there is a technology on magnetic micro robots. So, as far as the key features of these magnetic micro robots includes a low cell toxicity, it can be remotely actuated and controlled. It has a kind of a reconfigurable locomotion modes, a tunable structure and a morphological and a chemical features which exhibits. it has a high maneuverability, and it has a long-term open loop stability. So as far as application perspective point of view, it has a structured construction with cell transporting, a bioartificial, and it has a drug delivery and a bacterial inactivation. So in most of the cases, this has a potential application towards biomedical related domains, focusing more on the cell transportation and more on the targeted drug delivery. So these are some of the key applications where these magnetic micro robots effectively plays a vital role. So as far as mechanical perspective point of view, so we have a mechanical gripper in place. When a mechanical system comes into the picture, automatically the system has to be completely inspected. So there should be a kind of an in situ monitoring in this system, so that these in situ monitoring will be helpful for us to monitor the overall performance of this gripper. So either this in situ monitoring can be through a kind of a image processing. In certain cases, lasers can be used to measure the displacement in such kind of structures. So ideally in these features, we have a closed loop system. There is a position offset compensation in place, a hybrid force, a position, and a visual servo feedback control which exhibits over here. So basically it is available for light microscope and scanning electron microscopes. Multiple micro grippers and end effectors can be efficiently used. As far as application perspective point of view, it is used for MEMS assembly. It is also used for 2D and 3D pattern construction. So these are some of the applications and the field which are used. Now, if we try to consider the optical field, so we have discussed a lot about this optical tweezers. So as far as this technology is concerned, so we have the light and then we have optical tweezers in place. When we try to consider the light, there is going to be a stable optical matter arrays, hierarchically a self-organized and kind of it tries to gather in an aqueous media. So as far as application perspective point of view, there is going to be a kind of an electrodynamic interaction, a photochemical micromotor which exhibits, and then there is going to be a kind of a plasmonic antenna which is going to exhibit over here. When we try to look into the optical tweezer perspective point of view, it's a kind of a no stiction system. It has a capability to capture a multicellular organism based capturing system. It also has a kind of a capability towards automated recalibrations routines, and it has a high efficiency and a closed loop control. As far as application perspective point of view, it has a structured construction and a kind of a structured patterning. It has a kind of a cell recognition and a isolation assembly, a transportation, deposition, and a cell-to-cell adhesion with the hydrogel. So these are some of the key applications with respect to optical field perspective point of view. As far as acoustic field perspective point of view, which we had already discussed in detail about a kind of a acoustic based manipulation. In the case of an acoustic field, so we have features which includes the closed loop, the position offset compensation, which is considered to be a part of this closed loop for appropriate deviation in the displacement. Then there is going to be a kind of a hybrid servo force or a position and a visual feedback control which will also participate. And then certain amount of light microscope, multiple micro grippers and end effectors are considered to be some of the key features. As far as application perspective point of view, these microparticle assembly and separation, it has a kind of a synthetic motor and a protein reductions are considered to be some of the key applications. So ideally, if you see in this, these regions are more focused towards bio. However, these are for other domains. Now, with reference to acoustic field perspective point of view, there is one technology which is called as directed self-assembly technology. So as far as these directed self-assembly technologies are concerned, like appropriate magnetic field is induced to self-assemble itself for a particular, for a specific application. So like it is more focused and oriented for a specific application. As far as features perspective point of view, water environment, it has a kind of an orientation control. It has a kind of a non-spherical particles, and most important, it quantify and reduce the position and orientation error. So application perspective point of view, so we have the 3D printing of material, a nanoparticle assembly, and a kind of a structured construction which exhibits. In addition to this, when we try to look into the technology, we have a kind of a ultrasound driven based system. When we try to look into the features, so we have a non-contact base, a design for a kind of a weak substrate and a kind of an underwater environment. Application perspective point of view, a manipulation of living cells and organisms, and ultrasound driven gripper and a kind of a targeted drug delivery are considered to be some of the key applications of this. In addition to this, the bubble based systems are there. Then there is a water droplet based systems are there. Bubble based systems we had discussed in the last module also. It's a kind of a liquid environment. Basically, it has a kind of a module posture control, and it's a kind of a multicellular microstructure built, and it's a kind of a micropart assembly. When we try to look into the water droplet, the capillary forces with low requirement on precision is considered to be one of the key features. Now, with reference to application perspective point of view, the cantilever structures are built and appropriately oriented to this particular system. Now, let us see the overall fundamental of this gripper based microassembly. So, as far as in this gripper based microassembly is concerned, so this is a simple gripper based microassembly where there is a kind of a object which is moving, and the overall orientation of the object is controlled by the gripper. Now, it can grasp, it can perform three operations. One is a grasp, placing and releasing. Now, as far as the force which is evolved in this is a kind of an adhesion force which exists. So, within this adhesion force, let me just classify this adhesion force appropriately. Like, one is a kind of an electrostatic force which is arised from the charge generation or a kind of triboelectrification or a kind of a charge transfer during the contact. Then we have a van der Waals force. It's a kind of an instantaneous polarization of atoms and molecules due to the quantum and the mechanical effect. As far as surface tension perspective point of view, this surface tension is due to the interaction of layers of the absorbed moisture on the two surface. Okay, so these are some of the forces. So we will discuss about these forces in detail in the upcoming lectures.